So in this video, we are going to go through an example of calculations for a one-step problem, a one-step equation, and specifically it's using the mcAt equation because we have a change in temperature. So in order to know all of that, obviously I told you, but you need to be able to identify that for yourself. So when you read the question, you always want to be looking for, is there a change in temperature or not? And in this case, I see that it says this thing increases from 25, can you even see that? It's purple, 25 degrees Celsius. You can't really see that. Here, I'll circle it. So 25 degrees Celsius to 48. So we do see a temperature change. As soon as I see a temperature change, I know that I'm using the mcAt equation. Oops, delta T. So to get started, you always want to identify your variables. Usually the biggest place student gets stuck is they're not using the right variables or they don't know what they need in order to, calculate it. So knowing what equation I have, I can identify the variables. I'm always going to have Q. Q is my energy. I'm going to have my M. I'm going to have my C. And I'm going to have my delta T. And I can hopefully pick 3 of these 4 out of the question and then solve for whatever's unknown. So if I'm reading through this, the temperature, blah, 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 a mass of 95.4. So that's going to be my M, 95.4 grams. Has the temperature increases from 25 to 48. So remember, delta T is T final minus T initial. So I'm going to have 48 minus 25, and that gives me, 23, I think, hopefully. I'm doing that in my head. I don't do math in my head. So that's our delta T. Continue reading. When the metal absorbs 849 joules of heat, and remember, joules is heat, which is energy, which is Q. So that's going to be right here, 849 joules of energy. So you need to be able to pick out all of the pieces, including what the question's looking for, because it's not always like just because I don't have C filled in here, that doesn't mean that C is always going to be my unknown. There might be more steps than that, but in this case, it does want the specific heat, so C is going to be my X. And now we just plug it in. So I know that my equation, let me get a different color here. So I know my equation is Q equals MC delta T. And I'm just going to plug each variable in. I have 849 equals 95.4 times C, that's my X, times 23 degrees Celsius. This is my grams, and that's my joules per gram degree Celsius. Okay, and now to solve for C, I can multiply 95 times 23. Let me grab my calculator real quick. So 95.4 times 23 equals 2,194. So I have 849 equals 2,194.2 times C. And to get C by itself, hopefully we just divide both sides by that 2194.2, divide 219, oh gosh, it's 4.2. This cancels out, and then finally C equals 0.387 joules per, oh, whoops, this is only joules, I'm sorry, that's Q. This one is joules per gram degree Celsius. Hopefully you caught that. I made a mistake. Everybody makes mistakes. Did you all just say in your head, everybody has those days? I hope you did. All right, so again, here's an example just for calculating a one-step problem when there is a change in temperature, a thermal change. So if I were to sketch this graph, I would see that I have a temperature going from 25 to 48. My temperature's increasing. I see a thermal change. So going back to our, oh gosh, where'd that go? Our other notes. Oh, I think it's on the same page. Here we go. Going back to our old notes, if I see that increase, then I know I'm using my MCAT equation. And we did, and we got an answer, and now we're good to go. Thanks, guys.